Okay, so for this last Learning Target Tracker video for this week, it says I can explain how enzyme concentration can affect reaction rate. All right, so if you think about the enzymes as the little worker bees, okay, they're the ones doing the work. Okay, and let's say there's just all kinds of substrate. Okay, it's like you walk into Miss Piro's class on Monday, and you think, oh, it's going to be a good week. And then she gives you your checklist, and you're like, oh my goodness, look at all this work. Just kidding, guys. Not really. So here's the enzymes, and here's all this work. And they're like, there's no way we're going to get all of this done. Well, if you increase enzyme concentration, so you add more enzymes, let's say these first couple of guys, they start working away at the substrates, okay, turning them into products. But they just can only work so fast. Well, when you add more enzymes, now there's more workers, and they can knock the work out faster. So what you see with this, as you increase enzyme concentration, okay, so as it increases, you see the reaction rate increase as well. So more enzyme means more faster rate, so you're producing more product in the same amount of time. And that's simply because you have more workers. All right, what if you have substrates? Okay, so there's our enzymes, and let's say that's it. There's no more enzymes to come work. Okay, there's just those, what, 7? And we just keep adding more, and I'm not going to put a bunch of S's just in the interest of time. Just know that these are all substrates, and we just keep adding more and more and more and more and more and more substrates. Okay, can these enzymes work any faster when there's still only 7 of them? No, they cannot. What's going to happen, what you're going to see as substrate concentration increases, rate, is you're going to see it start to rise, okay, as enzyme number 1 starts to work, and enzyme number 2 starts to work, and enzyme number 3 starts to work. And so what you're seeing with this rise is you're seeing more enzymes coming to work. So this is like 1, 2, 3, 4, 5, 6, 7. But once all 7 are busy, they can't work any faster. It doesn't matter how much more substrate you add, they can't work any faster. So the rate goes to 0. It's not that it's not happening, right? It's not that it's not making product. It's just not making it any faster. Remember, rate is the amount of product formed over time. So they're still making product. They're just making it at the same rate because they can't work any faster. So substrate concentration, you're going to see it rise to a point, and then it's going to level off when all of your enzymes are busy. That point is called, you may see this, you may not, Vmax. It's just the fastest that the enzymes can work. And so that's a limiting factor, is the number of enzymes and how fast they can work. All right, the last thing, I can statement, is I can explain how product concentration can affect reaction rate. Well, in reality, sometimes it doesn't, okay? So sometimes you convert all of these substrates to product, and the enzymes go home and take a nap, okay, and it's done. But in a chemical reaction that is at equilibrium, remember, if you produce too much product, it will go in the reverse reaction to stay at equilibrium. And so what you would see here is and usually the enzyme that catalyzes this reaction, this reactant to product, can also catalyze the reverse. So the same enzyme is probably working. And so what you would see, and you won't see graphs for this, it would just be a concept that they would want you to understand, is that if you got too much product formed, you would see that enzyme start to convert some of that product back to the substrate or the reactants. So you would see it kind of go back and forth until it met a homeostasis or a balance. The last thing says I can analyze enzyme activity and rate of reaction graphs to determine how environmental factors affect this enzyme. Okay. All right, and so what we would see is like with pH, if it's a stomach enzyme, you're going to see it work really well at low pHs and not at all. If it's a neutral enzyme, you're going to see it like that, okay? So let's say that's 7, that's 1, 2, on up to 14. 114. If it's temperature, what you're often going to see, is you're going to see it rise, get to near its optimum temperature, and then it's going to pretty much crash. So this up here, these are your optimums. So optimum pH, optimum temperature. Okay, and we talked about why. We talked about how it's colder as you warm it up, it's going to increase. And then when you reach denaturation, it will drop. Salt concentration. You oftentimes see a graph like this. So you're seeing as you increase salt, you decrease the amount of or the rate of the reaction, the amount of product formed. And then the enzyme and substrate we talked about there. So as you increase enzyme concentration, now eventually you're going to run out of substrate, and so your rate is going to drop to 0 with this one as well. So that's when you have no more substrate. And then of course same thing here, substrate, when all of your enzymes are busy, then it levels off. The only other ones I can think of to talk about is when you add, and we talked about this in another video, when you have your normal enzyme, it might be at this rate, but then, and this is time versus product formed, but when you add an activator, it's going to happen faster. You could also look the same for a coenzyme. So when you add a coenzyme, it helps that enzyme, and so it's going to happen faster with a coenzyme too. Coenzyme. And then with the inhibitor, what you're going to see is this is normal. This is product formed and time. And with the inhibitor, you see it either drops it to 0 or fairly close to 0. So those are just some examples of enzyme activity and rate of reaction graphs, and how different things like activators or coenzymes or inhibitors can impact them, or how enzyme concentration impacts it, or how substrate concentration impacts it, and then also some environmental factors like pH, temperature, and salt. And so just make sure you're familiar with those. Y'all are pretty good at reading graphs, so I think you'll be fine. But I just want to make sure you know how to do those. And that's that. If you have any questions, let me know.